Today we'll be discussing about the computer hardware. On our previous lesson, we were discussing the application of the ICT in different areas. Like for example, how ICT has brought some revolution in different industries. Like for example, education, hospitals, businesses, communication, and so forth and so forth. So, and then you already have the notes for the same. So I'll request you people, you make sure that you go through those notes. It is very important there. So now, today, we are discussing another subtopic, or we can say it's a topic for that case, about the hardware. So what is hardware, students? So I wanted us to simplify this thing. So the hardware is the, it is the physical and the tangible components of a computer. Anything you can see, anything you can touch, anything you can feel, that is the hardware. So 99%, let us say about 90% of a computer is made up of hardware. It is made up of hardware, and then it is the visible because it is the one we can see, the one we can touch, the one we can feel. Unlike the softwares, we can only see the word. We can see only what it does. So the softwares, they're just instructions to the computer hardware. They tell the computer hardware what to do and also how to do it and then when to do it. So that is a what? That is the hardware. That is the what? That is the hardware. But for the softwares, it is not visible. For the softwares, it is not visible. But today, we are not concentrating on, let us focus on actually the hardware. Let us focus on the hardware part of a computer. So the first thing we should know, the computer hardware, the hardware is the physical, it is the physical and the tangible, It is the physical and tangible. It is the physical and tangible parts of a computer. It is hardware is the physical and the tangible parts of a computer. It is the physical and tangible parts of a computer. And then in the hardware, we have a very long categories of the hardware. We have a very long, we have what we call the categories of a computer hardware. Categories of computer hardware. So categories of a computer has been categorized into what? One, we have the input devices. We have the input devices. We have the input devices. What is this? What do I mean by the input devices, students? These are the devices we use to feed in, or in other words, to enter in, the data and instructions to our personal computers or to our computers. So these input devices, without the input devices, it will be very difficult for us as human beings to do or to communicate to our computers. We need to have the input devices. These input devices are likes of keyboard, the likes of keyboard, the likes of mouse, and many other input devices, but these are the main. We have the keyboard and then we have the mouse. And then under the keyboard, we have the keying devices. We have the keying devices. And then also under the mouse, we have the pointing devices. So we can, by pointing an icon or by pointing an item in the computer, you are entering what? A command. Or maybe I can select it, I can double click to open a folder. I can right click to rename or to change even the icon of a folder. So keyboard, we use it to do what? To key in data, to key in the data and instructions to our computers. While the mouse it is appointing, we have appointing devices there. You know, you point on an icon in the computer, and then maybe you double click, maybe you right click, and so forth and so forth. So input devices, we have what? We have the keyboard, and then we have the mouse. We have the keyboard and mouse. But in simple terms, the input devices, they are those devices which are used by the users to feed in or to enter in the data to our computers. And then you remember, we had said that we have what we call a data. And then what is this data? We say this data is the what? Is the raw, it is the raw parts. It is the raw parts, or in other words, they are information in a processiwa. So the information which is not processed is what? Is a data. Once if you convert, if you process this data, if you process this data from one standard to the other, now we call it the information. So now, and in the input devices, you find that we use the keyboard to enter in the data and what? And instructions. To enter in the data and instructions. And then I remember well telling you that, you people, I use an example like, for example, 1 + 2. So we say that all of us, we agree this one is a data, this is the raw data, this is the raw parts or the VCAF. And then also we say that this is the instructions. This is a very good example of the instruction. The instruction for this case is, can you add 2 to 5? Can you add 2 to 5? That is the word, that is the instruction. And then we say that if you get the answer which is 7, this is the equivalent to the word. This is equivalent to information. This is equivalent to what? To the information. So the output is the information. So maybe it cannot make sense because of some numerics I've used here, or because of these simple values. But now the output, assuming that ulikuwa una process a payslip, or ulikuwa unataka kuona ile kampuni imetengeneza profit or something like that. So the final thing is the information. That information, it can be used by the organization to make a decision. To make a decision is seen, this information inaweza saidia kwa kampuni make a vital, it can make a what? A decision. Whether, the company is profitable or company is running a loss. If it is running a loss, you know what will happen. If it is making profit, you can also, in your case, this is as good as mine. So, the input devices. So this is one category of the computer hardware. One is the input devices. And then number two is the processing devices. Processing devices. So we also have the processing devices. Processing devices, students, they are those devices that which does the actual execution. What do I mean by that? It is the devices which process the data from the raw to a meaningful information. And then this processes is actually, like, for example, in a computer, we have what we call old state. We have the old state. We have what we call the ready. We have the ready state. Sometimes we refer this as a ready queue. We as well have what we call the running. We have the running. We have the running state. We have the running state. We have the finished state. So these are the states we have in a computer. We have the hold state, we have the ready state, we have the running state, we have the finished state. So now in the processing, we have a topic we will discuss under a topic, we call it operating system. Under the operating system, we will be discussing something to do with the what? With the process management, because there must be a coordination. There must be a coordination, as far as processing is concerned in a computer. So what I mean by the coordination what I mean by coordination is, you know, since the computer, it has only one CPU. The computer has only one CPU. It has only one CPU. That is, it has only one central processing unit. Computer has only one CPU. So that is what you need to know from today onwards. And then sometimes in a computer, different or several or as many what we call the processes, so many processes, they find themselves in the ready queue. So what do I mean by that? So sometimes many processes, they can find themselves in the ready queue. Like for example, here we have the process 1, we have the process 2, we have process 3, we have process 4. We can as well have process what? Process 5. So in other words, we can have so many processes. We can have as many processes as comes of. We have so many of them in the ready queue. So what I mean by ready queue, it means that they are ready to be processed. They are ready to be processed by the what? By the processing devices. The processing devices, that is what? The CPU. But now the challenge here is we have only one word. We only have one CPU. We only have, each computer has only one central processing unit. And then since we only have one CPU, and only that CPU can only, you know, the CPU can execute one task, or it can process one task at a time. You know, IES process so many processes. These are the processes. IES execute all the processes at the same time. So it is one process at a time. Since that is the case, so it means that now we need to have what we call the process management. There must be algorithm where how we do what? How we assign these processes to the what? This one CPU. So we have different, you know, algorithms. We have different algorithms. We have, maybe we can use the fast come, fastest serve, you know, the shortest job fasting. We have the round robin and many other algorithms. But the facts remain that under the processing, you know, under the processing devices, we have the CPU, and then this CPU is one, and then sometimes several processes. The processes yenye huwa inafanya nini, you know, which is you know, issued by the users. We can have several processes zenye ziko ready zinafaa ziprocessiwe, but now inangojea the resource. The resource for this case is the CPU. It is waiting for the CPU to work, because CPU in execute one process at a time. A very good example is that when you are in a cyber cafe, you'll find that the cyber, ukikaa kwa hiyo computer, there are other customers or there are other users there. So those users, they have different tasks. Somebody anataka to print the timetable, somebody else maybe ana print the photo, somebody else ana print CV yake, somebody else printing the certificate, so all those is what we refer as the processes. These processes, they go to the what? They go to the ready queue. They go to the ready queue. So the ready queue, it is not in a hold state, the ready queue. So this ready queue, it is waiting to run. And then for only to run, it has to be assigned to the CPU. And then in this CPU, we have other components. CPU, we have other components. One component is we have what? We have control. We have control unit. We have the control unit. And then the control unit acts as a manager. We have the control unit. This control unit acts as a manager in the CPU. It is like mwenye anasema kwa CPU. It controls what is coming in and what is outside the what? The CPU. In other words, there is nothing which will take place. There is nothing which will take place in the what? In the CPU without direct contact to the CPU. So it is like the manager. It is like the manager in the CPU. And then also we have the ALU. We have ALU. Or ALU stands for what? Arithmetic. It is 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 arithmetic logic unit. It is arithmetic logic. So this, as it sounds, arithmetic logic unit under the CPU, we have two parts there. We have the part which deals with the arithmetical part, that is the multiplication, subtractions, and addition, and so on and so forth. And then we also have the logical unit, which does with the logical operations, that is like greater than, less than, not equal to, and so on and so forth. So, and then apart from the control unit, and then also the ALU, that is the arithmetic logic unit, we also have what we call, we have the main memory unit. We have the main memory unit. What is the main memory unit? The main memory unit is the primary computer memory. We have the primary. And then, what we mean by the primary memory, computer cannot do without it. Computer cannot do without the random access memory. Computer cannot do without what? Without a RAM. And then this RAM is what we refer as the random access memory. And then its units, we have it in terms of, initially we had the megabytes. We have, the unit was in form of MB. And then nowadays we have what? GB. GB, that is what? That is the gigabytes. So also, this RAM, it is the working space. It is the working space of a computer. When you download something, when you are typing something, when you are using that Excel you are using, when you are using that Microsoft Word you are using, when you are using any application software, any software, if you download it to your computer, you know that you are using the RAM. So hiyo ndio inakuelea that whatever you are doing. So it is not a memory which, so this memory also, this inakuelea temporarily as you work on whatever you are working. So, but only whatever you are typing or whatever you are processing, it will be only permanent if you save it in a secondary storage device. It will be only permanent if you save it in a secondary storage device, meaning that if you save it in a different location, not the RAM, because RAM cannot save your work for future. It is only a working space. It is only a working area of a computer. Random access memory, that is the computer primary memory. And then actually this makes up to 70% of what? Of the primary memory. Another primary memory is the what? Is the ROM. So this one is 70%, this one is 70%, the random access memory, and then this is the 30, this is the 30%. So these are the main memory unit. What is the responsibility or what is the duties of the main memory unit? So before any task or before any process equal allocated to the central processing unit, it means that it has to be within the what? Within the primary memory. And then also, once the process has been run, and then it has been processed, and then it has reached its termination, now it has also to go via the what? Via the random access memory, awaiting for the user, awaiting for the user instructions or the user IO, input to do what? To save that work in a different location or even to print or any other thing. So the primary, the main memory unit play a big major role during the processing. And then now you need to know that, as I have said, that in a computer, so we're just discussing about the what? The computer hardware. And then we have said that the computer hardware is the physical and the tangible parts of a computer. And then also we have the categories of a computer hardware. And then we have also said that the computer hardware has how many categories? We have the input devices. The input devices, students, they are those devices we use them to feed in or to enter in information or to enter in the data and instructions to our personal computers or our laptops or any what? Any computer for that case. And then now well, we say that a good examples of these input devices is the keyboard and the mouse. We have also the processing devices. So these processing devices, we have the CPU. Under the CPU, we have also the other components which work hand in hand. You know, these are the components which are inside the CPU. For the CPU to perform any execution, there must be what? A control unit. There must be what? Arithmetic logic unit. And then we must have also the main memory unit. And then also the main memory unit. And then these processing devices, they will relate these processing devices with the operating system. Because under the operating system, it is where we manage the processing. There must be management of the processing because we only have one CPU. So we must come up with a criteria which process is assigned to the CPU and then why. We have different algorithms. One, first come, first serve. So what I mean by the first come, first serve, we'll find that these processes, they have their arrival time. These processes, they have their arrival time. Kila process iko na arrival time yake. So we can say that we can assign these processes to the central processing unit, coding or tukitumia criteria, the arrival time. So the arrival time for that case is the criteria. The arrival time is the criteria. So the arrival time is the criteria. Like for example, if the process one, it arrive before process, if it arrive, zote ziko kwa ready queue, but now we prioritize the what? The arrival time. Ile yenye imetoka kwa old stage ikakuja kwa ready queue, ile yenye ilitangulia ndio tuta-assign the CPU. That is first come, first serve algorithm. That is the first come, first serve algorithm. And then also we can use another criteria. We can also use another criteria, the shortest job first. We refer it in a computer as what? As the first time. As the first time. So what do I mean by the first time? So the first time thing is when I assign a process to the CPU, this process either take time gani, it'll take how long? It'll take how long? Is it 8 units of time? Is it 10 units of time? Is it 100 units of time? That is what we refer as the first time. So now if our criteria or if our algorithms is that the shortest job first, it means that we will assign these processes here. We will assign these processes here. The process ile inachukua time kidogo kwa CPU ndio tuna prioritize. That is what we will prioritize. The task yenye, the process yenye inachukua the shortest job, yenye inatukia the shortest time. Like for example, if I'm printing one page and then my somebody else there is printing, maybe is printing 200 pages for that case. So I will prioritize here page moja because this one page will take the shortest time possible. That is the word. That algorithm is the word, the shortest job first. And then also we have the priority scheduling. We have the priority scheduling. What is the priority scheduling? The priority scheduling is the criteria where assign, we will allocate the CPU, we will allocate these processes to the CPU according to the priority. So if the priority is 1, So we will just prioritize. You know, we have the priority table. It shows us the priority for each and every one, for each and every process. The same thing applies to let us say our real life. A real life, there is some things which even you yourself you can prioritize. Even if you have that your salary, that the salary you have, you can prioritize. Those things you cannot do without, like for example the renting and so on and so forth. And then also we can say let us say in the hospital also they do prioritize according to the emergencies. Ukienda kwa emergency kuna wale wagonjwa wanakuwa prioritized because of the situation or because of the status of the world of the mgonjwa, or for that case of the patient. So they do prioritize. So the same thing applies to this let us computer. Kuna ile kitu inafaa ikuwe prioritized. Maybe there is a reason why it has to be processed first. Like for example, in the organization, mimi nikitumana kitu and then director ametumana. Most cases, the receptionist ladies, they will do what? They will prioritize the director's what? The director's work. But for our case in the IT, what we do, we have the priority table. We have the priority table. So your priority table ndio utassign according to the priority. And then not arrival time. Not the arrival time. The arrival time is the what? But also, you cannot prioritize something kama itaingia kwa dedicated. So that is why arrival time also is very important in this case, in the priority schedule, in the priority. Yeah? So it is something we'll discuss more about this. It's about what we call the operating system. So, but at least now you have an idea, or at least you have the overview. So we have said that, and then categories of a computer hardware. Don't worry about the notes. I will just share the notes. What is very important is the discussion. What is very important is discussion. We can even do the discussion today, and then we can write the notes tomorrow. We can write it. So we have said that input devices have simply discussed that the keyboard, that is the keying devices. We'll be writing something about the keying devices, like the keyboard, like pointing, like many other things. We have the mouse. Mouse is pointing devices. I will list a long list of the pointing devices when we'll be writing our notes. But this just about a summary. And then I'll be expecting you to go back at the back of your exercise book. You do a summary of what of this topic hardware. So tumesema the hardware. Hardware is the physical and the tangible components of a computer. And then these hardwares, they have the categories. So categories of a computer hardware, we have the input devices, we have the processing devices, and then also number three, we have what? We have the output. We have the output devices. We have the output devices. So the output devices, they are those devices which we obtain the information from. So once the information is processed on a computer, we need at least to have, to get the output, or in other words, to get the results. How do we get the results? We only get the results through the output devices. So these output devices, they are in two forms. One, they are in form of soft copy. And then also they are in form of the hard copy. So it is soft copy and then the hard copy. So what do I mean by hard copy and soft copy? So the hard copy is the printed one. The printed one. So if I print something from my computer, it means that you may obtain that information in the what? In hard copy. In hard copy. And then the soft copy is the one we do what? Yenye tunasoma kwa computer screen. It's the one yenye tunasoma kwa computer screen. So we obtain of output devices, we have the soft copy and then we have the the hard copy. And then also, number 4 is we have the storage. We have the storage. We have the storage. We have the storage devices. We have the storage. We have the storage devices. We also have the storage devices. Those the storage devices, they are still also categories over computer hardware. They are also the categories over computer hardware. So I wanted us to write something. Let us to write something. So I wanted us to write this. Computer hardware, computer hardware, computer hardware, computer hardware. So the computer hardware, computer hardware is the physical and the tangible parts of a computer. They are the physical and the tangible components of a computer. They are the physical and the tangible parts of a computer. And then also computer hardware can be categorized into the following. Computer hardware can be categorized into the following. So one is input devices. One is the input devices. One is the input devices.
Huh?
I'm sorry. So the input devices, they are devices plus the gadgets. So we write input devices. So computer hardware can be categorized into the following: input devices, they are devices plus the gadgets, devices plus the gadgets, they are devices plus the gadgets used for entering data into the computer. They are devices plus gadgets used for entering data into the computer. They convert data from human readable. They convert data from the human readable format to a machine readable data. They are devices plus gadgets used for entering data into the computer. They convert data from human readable to a machine readable data. They are classified according to how they enter data in the computer. I repeat, the input devices, they are devices plus the gadgets used for entering data into the computer. They convert data from human readable, machine readable to machine readable data. They are classified according to how they enter the data in the computer. So the classification of input devices, one is the pointing devices. The pointing devices are input devices that are used to enter the data in a computer system by accepting items on the screen. Input devices, they are devices plus gadgets used to entering data into a computer. They convert a data, classification. We have the pointing devices. The pointing devices are devices that are used to enter the data into a computer system by accepting items on the screen. They may be used to give instructions to computer. They may be used to give instructions to the computer. Examples is one is mouse, joysticks, light pens, trackball. So we have the trackball. We have the trackball. And then touch bar. Then we also have what we call a touch. We have a touch bar. And then also we have the keying devices. The keying devices are input devices used to enter the data by typing, e.g. the keyboard, keyboard, keying devices are input devices used to enter the data by typing, e.g. a keyboard, keyboard. Roman 3, scanning devices. Scanning devices. There are devices used to capture data through scanning. Scanning devices. That is the classification. Classification, we're still writing something about the classification of the input devices. So we have the folding devices, we have written something there, we have the keying devices. Now we are in scanning devices. The scanning devices. The scanning devices are used to capture data through scanning. Used to capture the data through scanning by converting the hard copy images, e.g. optimal mark reader, used to capture data through scanning by converting the hard copy image, e.g. the optimal mark reader, OMR, in bracket OMR. Optimal character reader, comma, and then we have also the optimal character reader, OCR, in bracket OCR. Also, comma. So let me just repeat. The scanning devices used to capture data through a scanning by converting hard copy image, e.g. the optimal mark reader, that is OMR in bracket, comma, and then optimal character reader, OCR in bracket, and then also magnetic ink character reader, MIC. Examples of scanning devices. One is the OMR. That is the optimal character reader, used for sensing marks. Stroke a paper, stroke a document, each used for making multiple choices exam. So these are the what? These are the what we call, so scanning devices, OMR. These are the devices in a mark. These this exam is multiple choices. That is why unaona exam ya ADD ilitoka within a week, because they were just using a scanner to mark their exam. And then also another example of a scanning devices is the OCR. And then the OCR is magnetic. OCR is the optical character reader. So used to sense the presence of magnetic characters in the paper. Used to sense the presence of magnetic characters in the paper. Used to sense the presence of magnetic characters in a paper. Output devices. So the output, a unit of a computer system, the output unit of a computer system hold the results in a human sensible format. The output unit of a computer system hold the results in a human sensible, or in other words, a human readable format. It communicates the processing results to the users in a number of formats. in a number of format. So one is the soft copy. 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 Soft copy. This is the output that can be seen or add, but can't be touched. E.g., the monitor, e.g., the monitor and speaker, e.g., the monitor and speaker, e.g., the monitor and speaker. This output that can be seen or add, but can, so soft copy, this is the output that can be seen or add, but can't be touched, e.g. the monitor, speakers, and then projections. Then the project, or we can say projectors, monitors, speakers, and projectors. Then the projectors, And then also we have the hard copy. The hard copy, these are printouts. These are the printouts on the stationery or materials, e.g. The photocopy, e.g. the photocopy, the hard copy, the hard copy, the hard copy, the hard copy. These are printout on stationery or materials, e.g. the photocopy, the blotters, used for graphics printer, used for the graphic. Blotters, it is a big printer in printing large images, like these things being used by politicians. Easy, unaona pana kubwa, so they use the blotters. Blotter is a big printer. So the difference between types of printers, the difference between different types of printers. So the difference between different types of printers. So I wanted us to write those difference. You have a table there, and then in that table, we have the impact printers, and then we have non-impact printers. Impacts and then non-impact printers. So can you write the difference there? The difference of the impact and non-impact printers, kindly. So kindly write those notes. I'll type it here. So we have the difference between the types of printers. So we have the impact printers and then we have non-impact printers. So impact printers are printers that have print aid. They have the print aid elements and creates an image. They are the impact printers, they are printers that have the print head elements and create. So I think there is some repetition there, and creates an image. And create image having print head come into contact with the inkjet ribbon on the surface. While non-impact printers are the printers that produce image either via the electronic or thermal technology, or what we refer as a thermal technology. They don't have a print head element and are quiet while in operation. But now the impact printers, makes a lot of noise. It makes a lot of noise. And then another difference is that they are cheap to operate and produce poor quality printout. That is impact printers. Impact printers also, they are cheap to operate and produce poor quality printouts. Examples are dot matrix printers, daisy wheel printers. Examples are dot matrix printers, daisy wheel printers. They are relatively expensive to acquire and maintain. That is, what do we call the non-impact printers? They are relatively expensive to acquire and maintain. And then they produce high quality output, each lesser printers and inkjet printers and inkjet printers. So the processor, that is the CPU, the processor, that is the CPU. So the processor, it is still part of the what? The input device. It's part of the hardware. So we have the processor, that is the CPU. CPU is a device used to transform data into information. The CPU is a what? The CPU is used to, the CPU is a device used to transform data into information in a computer system. So the processor accepted data entered and pasted on the instruction provided, manipulates the data to keep a corresponding results to keep a corresponding results. Components of a processor. A components of a processor, as we had discussed earlier, we have the control unit. Control unit is used to coordinate and control the data processing activities as well as other parts of a computer. It works by fetching and sending the instructions, or in other words, it acts as manager. Control unit, CU, used to coordinate and control the data processing activities as well as other parts of a computer. It works by fetching and sending instructions. It works by fetching and sending the instructions. So that one we had discussed before, that we said the CPU has how many components? Three components you can see there. We have the control unit, and then we have also the arithmetic and logical unit, ALU. So arithmetic and logical unit, the ALU, is the unit that performs the arithmetic operations. It is the unit that performs the arithmetic operations and logical operations Arithmetic does the operations, that is subtraction, addition, multiplication, mode, division. So mode ni ile number inaappear in array, imeappear twice. And then also logical does these special operations, that is equal to, less than, greater than, or if not. And then also we have another component of the CPU by the name registers. So these registers is like what? It is like the MMU. It is like the main memory unit. So it is like the MMU. So it provides memory. It provides memory where data and instructions are held during the processing computer software. Softwares are intouchable. Oh, okay. That is, we are going to the softwares. I didn't want us to go to the softwares. So tuachane na hii ya softwares kwanza. So under the registers, I wanted us to, so maybe we add this under the registers. Kidogo tu I'm coming back. So I wanted us to continue from here, from this register, so we can write more information about the registers. So that registers, okay. So after the control unit, I think to mandika about the control unit, and then also we have the arithmetic logic unit. We have also written something about the same. Okay. So the main memory unit, kidogo, let me assist somebody and then I'm coming back. Okay, so I wanted us to continue to write something under the registers. So I don't know whether if it is possible, you can down there we write the main memory. We write the main memory. The main memory, and then we write this, the main memory of CPU, the main memory of the CPU consists of registers, there's one, and then random access memory, that is the RAM, and read only memory, This is discussed in the detail under the section on storage media in section 2.5. Section 2.5. Okay, I'm sorry. I'm really sorry. So don't write that one. So just write like this: the main memory of the CPU consists of the registers, random access memory, and read-only memory. Full stop. And then also I wanted us to write something about the data buses. The data bus. I mean, wanted to write something about the data bus. So the data bus is the highway. It is the highway of the data. Ile instructions inaenda from this component to the other. They use the data bus. That is the highway, the data. That is the highway of the data. So what is the data bus? These are also called the data pathways. These are also called data pathways. all components in computer are linked by electrical pathways. All components in a computer, are linked by electrical pathways called passes. The CU, ALU, and memory are linked by the following three pathways. The control unit, the arithmetic logic unit, and main memory unit are linked by the following three pathways. Control unit, a control path, sorry. It is control bus. This is the pathway for all the timing and controlling functions sent by the control unit to other parts of the computer system. And then we have also the address bus. This address bus, this is the pathway that is used to locate the position in the memory where the next data instructions, to be processed is stored. And then also we have a databus. This is a pathway where the actual data transfer takes place. This is the pathway where the actual data transfer takes place. So we need to see the factors to consider. That's still in the hardware. The factors to consider. So the factors to consider. When using a CPU. So factors to consider when using a CPU. So one is the memory. One is the memory size. So the factors to consider when using a CPU is one is the memory. So is the memory, and then this is the amount or the volume. This is the amount. This is the amount or volume. Amount or volume of data. That volume of data that the computer memory can hold. Computer memory can hold. So memory size, these are the amount of volume of data. This is the amount of volume of data that the computer memory can hold. Another factor is the speed. Another factor is the speed of the CPU. Is the speed of the CPU The speed of central processing unit. This is measured. This is measured. This is measured in this is measured in hertz, or in other words, gigahertz. This is measured. This is measured in hertz. So H set bracket. The higher the speed, the higher the speed, the higher the speed, the faster the processing of data. The higher the speed, the higher processing of, the faster the processing of data. The speed of the CPU, this is measured in hertz or gigahertz. The higher the speed of the higher the speed, the faster the processing of data. Some modern computers are so fast that their speed is measured in gigahertz. They are measured in gigahertz. And then another factor is generation. Another factor number 3 to consider when using a CPU is the generation of the CPU. Is what? Is what, students? Generation is the generation. So current generation computers are more powerful. Current generation of computers are more powerful. Current generation of computers are more powerful than the older generation. The current generation of computers, the current generation. Another factor, ukienda kununua that CPU unafaa uangalie the generation. Is it the older generation or the latest generation? And then the current generation computers are more powerful. They are more powerful than the older generation in terms of the how many instructions that machine execute at a time, in terms of the speed, in terms of the processing, and so on and so on. And then also another factor is the manufacturer. Number 4 is the manufacturer. Another factor is the manufacturer. It is important to choose a credible manufacturer. It is important to choose a credible manufacturer to ensure efficiency. So it is important to choose the credible manufacturer. Kama HP, we have Dell, we have the Lenovo. So kila mtu akona preference yake. All of us, we have different preferences. Myself, I prefer HP. So that is what? That is my manufacturer choice. I used for HP. So it is important to use the credible manufacturer. Use the credible manufacturer to ensure efficiency. Examples of popular CPUs are made by Intel, Motorola, AMD, and so forth and so forth. So tomorrow we'll continue with the computer storage media. Tomorrow we'll continue with computer storage media. And then we have a lot about computer storage, and then also factors affecting the performance. Tuangalie the factors affecting the performance of the CPU. what are those factors in affecting the performance of the CPU? That is also something tutaiangalia kesho. And then also the secondary storage devices. The secondary storage devices. Secondary storage devices also tutaiangalia. So let us stop there for today. We continue tomorrow. Thank you very much. We meet tomorrow.